Welcome to the TWIML AI podcast. I'm your host, Sam Charrington. One thing we consistently heard from last year's TWIMLcon attendees was the value of sharing the event with their teams and organizations. In fact, most companies sent more than one person, and we hosted entire teams from companies like Apple, Capital One, Ford, LinkedIn, Twitter, Vanguard, and more. There is a ton your team can gain by attending TWIMLcon AI platforms. You'll learn how to overcome the barriers to getting ML and deep learning into production, how to apply the latest MLOps and DevOps techniques to enhance the machine learning workflow in your org, the latest tools and platform technologies for accelerating and scaling ML, DL, and AI, and how to develop organizational and cultural best practices for success. You and your team will leave TWIMLcon with a practical blueprint for accelerating and scaling your ability to get ML and AI models into production. The conference presents a great opportunity for your team to come together, learn what some of the leading model-driven organizations in the space are doing, and lay the foundation for taking your ML efforts to the next level. To learn more about bringing your team to TWIMLcon, visit twimlcon.com/teams. All right, everyone, I am here with Peter Mattson. Peter is president of MLCommons, general chair at MLPerf, and a staff engineer at Google. Peter, welcome to the TWIML AI podcast.
Thank you very much for having me. You've built a pretty amazing thing with this podcast. I'm excited to be part of it.
Awesome. Well, I'm really excited to chat with you. In particular, today's a big day for you. You're launching something that is called MLCommons, and we will get into what exactly that is. But before we get there, or to get us there, tell us a little bit about your background and some of the work you do.
Sure. So by background, I'm a compiler guy. I like to work with complex systems and make them better through quantitative analysis. But these days, that means ML. That's where all the excitement and opportunities are. And so that's what I'm focused on now. I started with Google about 3 years ago and built up an ML metrics team. We're very excited about measuring everything about ML and using that to make ML better. Everything from speed to accuracy to efficiency. And so sort of as a natural outgrowth of that, we were part of a small group that founded something called MLPerf, which has grown into sort of the industry standard performance benchmark. So now I have sort of a dual role of leading my team at Google, and I'm the general chair. I try and herd all the cats for MLPerf, and that's, as you mentioned, becoming something new with MLCommons. So try and wear all those hats successfully. It keeps me busy, but it's a really exciting time. I mean, I think anybody in this industry right now. You're really fortunate. We're all a part of history right now. It's very exciting.
Well, let's start by talking a little bit about MLPerf and what you've been up to there. I don't think we've talked about it much on the podcast at all.
Sure.
Or if we've talked about, some of the issues there in terms of benchmarking machine learning performance, but, tell us a little bit about MLPerf and what that's all about.
Sure. So MLPerf is a ML speed benchmark. So it measures how fast you can do things like train models, or the kind of throughput you can get with a model for inference. So that is to say, you deploy a model to recognize cats. How many cats per second can you achieve? That's what it does. But we really needed something like this a few years ago. People were starting to build accelerators for ML. We'd turned GPUs into, people were starting to build dedicated hardware. But everyone was sort of claiming theirs was great, using very different metrics. And so we needed some way to get everybody on the same yardstick, so we could compare solutions and try and figure out what was the right direction for the field to go in. So that was the rationale for creating MLPerf. And I'd started at Google, and I was fortunate enough to connect with David Patterson of computing a quantitative approach, or computer architecture, a quantitative approach. He is a very strong advocate of using metrics to design things. And we decided we wanted to build this. So we looked around and found a group of people who published what we thought were good work in machine learning benchmarking. There was Greg Diamos, who'd done DeepBench, Mattei Zaharia and Peter Bayless at Stanford, who did DawnBench. There were some folks at Harvard who'd done Fathom. And we kind of got everyone in a conference room and said, we've got a bunch of good ideas here, but we need something with enough support that everyone starts using it. Can we all come together and build one benchmark? Fortunately, we had a lot of community-minded people, really great group of folks, and we decided to do that. So we drafted up some rules, overcame, I think, some really challenging technical problems in benchmarking ML. ML is unlike benchmarking normal software. We had to come up with some very different things. And then we reached out to the larger community and got some, everybody we could think of, and got some great folks involved from other companies like NVIDIA and Intel in particular, and a bunch of startups and some more academics, and just grew the community from there. We did our first round of benchmarking at the end of 2018, and then kept growing. That was a training benchmark. So how quickly can you get a model to go from 0 to the quality you want? Then we added inference, and now we've added benchmarks for mobile and benchmarks for supercomputers. And this community has really worked well together, and our benchmarks have taken off. We've been in The Economist and the Wall Street Journal. We're the way you measure how fast your ML hardware is.
And is the benchmark based on any particular type of model? Is it computer vision oriented, or do you have different versions? Maybe one that's more, transformers and NLP, another computationally intense workload?
So what we've tried to do is cover the whole field, because we want people to be able to either build specialized hardware or build general ML accelerators. Depends on what they're trying to do. Mm-hmm. So we have a suite of benchmarks, for instance, for training, that includes a couple of vision benchmarks, a couple of speech and language benchmarks, a recommendation benchmark, which is what powers search and commerce, and a reinforcement learning benchmark, which we think is reasonable coverage. There's some areas we'd still like to build that out in, but that's a pretty good survey of the field. Mm-hmm. And one of the things that we've always pursued since day one was making sure we benchmark real apps. Or real training tasks. Yeah. Training this model, ResNet on ImageNet, to give you the classic example, right? This is a very well-known vision model on a very well-known data set. This is something people really do. There's been a lot of failures in benchmarking history with people doing, quantitative approximations. And then people end up optimizing their hardware for these quantitative approximations, and it turns out to have nothing to do with reality. So we really wanted to build a benchmark that is things that people really do in these areas. For instance, BERT is very popular these days. It's one of our benchmarks. We're starting to look at things like the giant models that the people are using, like GPT, and see whether we can add something like that. We want to make sure that we have a benchmark that is real and that it tracks the amazing rate of progress in this field.
Yeah. And I imagine you alluded to this earlier when you talked about measuring cats per second, that one of the key contributions of an effort like this is to define what that metric is.
Yes.
I guess if you let NVIDIA define it, it's going to be flops or something like that. And, that might not be as relevant for another kind of architecture.
I will say that NVIDIA has been a strong proponent of the real benchmarking. I mean, they've been really
I'm not trying to be
work with, but
NVIDIA here.
It's very easy to end up going into some sort of technical cul-de-sac. But if you stay true to what people are doing, I think that works well. And as you wisely pointed out, the critical thing is to establish this common vector of progress and get everyone moving down that vector. And even if you're a little off from where the real value vector is, the acceleration you get, because you can stack everyone's progress. I go a little bit down the vector, someone takes my idea and goes a little bit further. Mm-hmm. The projection onto the real value vector moves very quickly. Whereas if everyone's claiming that their idea is better and you have no idea whose marketing department is telling the truth, or they could all be telling the truth from their perspective, it's really hard to get that kind of aggregation of benefit.
Yeah, yeah. And so MLPerf, it sounds like, is primarily used by those hardware vendors and folks that want to verify the hardware vendors' performance claims relative to one another. Is that the same audience that you're targeting with MLCommons?
I think so. Let's break this question down into two parts. Yeah, first is who uses MLPerf.
Yeah,
I will say that the primary use is probably either people wanting to compare their hardware against someone else, or people wanting to decide, what kind of hardware should I buy or use. That's probably our primary user, but that extends from supercomputing down to phones or even IoT devices. We've got folks working on right now.
Got it.
But that doesn't mean that that is all that it is useful for. And in fact, we're trying to do a better job of getting people using it to benchmark different software stacks or different optimizations. In particular, we're starting an effort to try and benchmark algorithmic efficiency using very similar techniques, because ML models keep getting bigger, and unfortunately, compute budgets are not infinite. So we need to figure out ways to do more with less compute, and we'd like to help with that.
What are some examples of the kinds of algorithmic efficiencies you're envisioning using MLPerf for, or some of the ways that you do that? Are we talking about like training parameters, like learning rates and that kind of thing?
Yeah, so you can imagine using better hyperparameter search algorithms, better optimizers, which are the things that take, your model makes a guess and then it's not a right guess, so you apply back the error to make it better, and the way you apply that back is determined by the optimizer. So we'd like better optimizers, or just better models. I mean, there are good and bad models in terms of efficiency. We'd like to really be able to understand and characterize that. But this is at a much earlier stage than sort of the hardware comparisons. Yeah. So, we want to be sort of serve the full stack. A little bit of investment in benchmarking for companies with big compute spends is a very good return.
And so MLCommons is MLCommons primarily being introduced to serve as a organizational structure behind MLPerf with the same set of goals, or is it attempting to broaden the scope, or are they totally independent? And
so they're a little bit of column A, a little bit of column B. So
okay,
as MLPerf grew, we were running it as an informal consortium, which means we had mailing lists and a shared drive. But we want this to be a durable thing. If you look at SPEC, which is the general purpose computing MLPerf, they've been around for 30 years, right? We'd like to be here 3 decades from now. And so we needed a durable organization to hold it. But in the course of trying to figure out what we wanted to do to get that durable organization, we realized that there was a bigger need that we could serve. We read all this hype about ML as being this incredibly advanced field, and look at all these things it's doing, but it's really very young. I mean, this is not transatlantic jet travel, right? This is the Wright brothers. Half the time the planes crash and we don't understand why. And so we need to build the things that help it grow as an industry. And I think that really does start with good benchmarks, good measurements. Understandings of what really is speed, what really is accuracy, what really is efficiency, and understandings that everybody shares, so that we're all talking the same language, the metric system, if you will. But we also need good raw materials. We need data sets, which is what everything in ML is built from. I don't think we'd have ML today if we didn't have ImageNet. ImageNet is, I'm told it cost about $300,000, and that the ROI on that investment is amazing. And we need more of that. A lot of our data sets, they emerge sort of organically from an academic project, and they go out in the world and they sit, right? And we really need continued investment in building great public data sets that everybody can use to both communicate about how good their approach to solving that class of problem is, and to build better solutions. And lastly, we need good ways of doing things, good standard ways of doing things. We need, for instance, ways of easily sharing machine learning models between, I'm a researcher, I want to give it to you, engineer, at a small business, and you can use it for something, right? How do I make that exchange as easy as possible? So we had a really strong community, and we saw a really big need for this kind of community infrastructure to turn ML into an industry. And so we decided we'd create a new organization to host MLPerf and try and take on this new set of tasks that we thought the community really needed. And so that's what we're doing with MLCommons. So MLCommons will sit on these sort of three pillars, we call them, of benchmarking, public data sets, and best practices. And we're working right now to start to build out those other areas. We've actually already started projects in those areas. We've got a lot of great people involved, but we want to get more people and more projects and help ML go to the next level and really deliver benefits to everyone.
Mm-hmm. On the last of those pillars you mentioned, best practices, we can explore the specific things that you're doing, but there's so much ground there to cover, particularly given, as you mentioned, kind of the still nascent state of machine learning and deep learning in particular, and how much of training models remains kind of dark art.
Yes.
Did you happen to come across or hear about the latest paper about the latest technique to do, XYZ to get your models to converge?
We need to turn that art into science, right?
Yeah, exactly.
And then into engineering, which is things that, people can easily pick up and use to solve real problems. I think there have been some early successes in ML, but there's a lot more that I think it can do. I think in particular, you look at some of the things it might do in healthcare. If you saw the DeepMind announcement recently about the protein folding solution for drug development, that's very exciting. I think there's a lot of opportunities there. Things it might do in automotive safety, right? Full self-driving, or a lot of things short of that, save a bunch of lives. The things it could do for communication and access to information, or the things it already does, right? It powers the search engines we use to find things. It increasingly enables things like voice interfaces and automatic translation that just make it easier for people everywhere to get to information. I think there's a lot of potential here, and we're in very, very early days.
Yeah. So let's maybe dig into each of those silos. On the benchmarking side, there's MLPerf. One of the things that I was curious about, when you go to the MLPerf website, kind of the lead tagline is fair and, whatever the rest of that tagline is.
Fair and useful.
Fair and useful. And, certainly when you're doing industry benchmarks, one of the key pillars is that you want to be fair to the various participants in that benchmark. But I think it also jumped out at me in the context of like bias and algorithmic fairness, algorithmic ethics, these kinds of conversations around which there's also a need for folks to have tools to benchmark their fairness in that sense. Is that something that working on, thinking about, decided not to work on, something already there?
So one of the things that we're doing sort of related to fairness and increased access is actually in the dataset side of things. A dataset, if you think about it, is really it is almost a benchmark, right? It's a test for your model. How well can you encode this data and usefully summarize it? So we're trying to construct a new data set called the people's speech, which is going to be roughly 2 orders of magnitude larger than any other public speech data set we know about. So that's about more than 80,000 hours of speech. It's roughly 10 years. And though it is still, because of what we can easily get started with, it's predominantly English. We've been able to include 59 different languages, at varying levels of support, in the initial data set. And I think doing things like that really broadens the reach of ML and makes it, fairer for a wide range of people. So that's definitely something that we're interested in. We are very much a technical organization and less of a policy organization. So if we can figure out how to quantify something, we're very interested in helping people make that better. I think it's a very worthy goal.
Mm-hmm. What led to the people's speech as kind of the place to start on the data set side of this, that particular silo?
And I think it was, you look at the big ML tasks, and there are some pretty good data sets in vision. Honestly, I think they could be better, but there's some really good starts out there. And textual data is a little easier to come by, but speech, I think one of the best data sets we have is recordings of the European Parliament. And you can probably guess about the demographic diversity of that data set. And so, it seemed like a really good opportunity to have an impact. And that's a lot of what we're about, is trying to find, opportunities for impact to improve sort of the ML ecosystem in a positive way.
Mm-hmm. And when you say it's a speech data set, is it audio only? Is it audio and corresponding text? What exactly is the nature of the data set?
So it's audio with corresponding text, right? This is how you train speech to text models, which is the thing behind a lot of speech to text interfaces. So without that labeled data, there are techniques that can get some value out of it, but it's so much easier when you have the labels. And so a lot of the work that we've done is figuring out how to take a large corpus of speech and produce a lot of that labeling in a very efficient way. That's what's let us get started.
Mm-hmm. And how have you done that? Is that like a crowdsourced, community-oriented effort, or
so we've
funding a huge labeling effort?
A couple of different answers.
Okay.
There's first of all, let's talk about what we're trying to do.
Sure.
If you think of coverage, we're trying to make a big data set. We're always still trying to make a data set with good coverage. Okay. Mm-hmm. And we can define that coverage along sort of two axes. One axis is how diverse are the languages and the speakers, right? Different people, different languages, different accents. The other axis is how real is the conversation. So is it people reading books, or is it people talking?
Yeah.
And if you imagine the lower corner is people reading books in English, right? That is the easiest place to start, right? And that's where a substantial fraction of our data comes from. But what that does is it gives us mass. And the way machine learning models work, you can imagine that if you have a machine learning model that can figure out, oh, that's a word, and that's a break in a sentence, these things transfer between languages. So that gives us our mass. And then we found other sources to bring in different languages, or slightly more realistic ways of speaking. And we plan in the future to invest in pushing both of those out. So we've got this good start, which is sort of a red, mostly English, but with a broad coverage of other languages at a lower level. And then we're going to push that out. The way that we got a lot of that was to acquire a bunch of content and then use some automated techniques to do the alignment. To, someone is reading this text and here's the recording, but, where is this word in that recording? And so we developed some good techniques for doing that. And that let us get to scale very quickly. Some of our other stuff is, drawn from a variety of Creative Commons sources and aligned in various ways so that we can composite the data set. Then what our plan is, and this is another thing that I think is important to think about when we're thinking about data sets. Is too often we think about data sets as someone made a data set for that, we're done. But that's like saying, that's Linux version 1.0, solved the open source operating system thing, we're done. Let's move on to the next problem. These are things where we need continued investment as we better understand, what sort of data we need, and how we can accumulate it and make it as useful as possible. So we've assembled a group of people, companies that help fund MLCommons, both monetarily and by contributing engineering resources or compute resources, and academics who bring a lot of vision and enthusiasm, and small companies, who contribute an amazing amount of work given their size, and assembled this group to try and create this sort of living data sets, starting with this one, but hopefully adding others in the near future where we have an impact and then we keep growing it.
Nice. And then on the best practices side, what's the initial focus there?
So for best practices, we want to start with some very simple things that are surprisingly hard to do right now. One of the simplest things in ML is to share a model, is to say, I've developed a model. I would like the world to be able to use it.
Yeah.
As it turns out, downloading someone else's model is pretty much a good way to write off a week. You got to figure out the dependencies. You got to figure out where to get the data from. Do you have exactly the data they used? Is it going to be compatible with the hardware you're going to try and run it on? How did they set it up for you to run it? It's some very basic questions, and it takes time to sort through all of that.
Mm-hmm.
And so we've started a project we call MLCube, which is basically to provide a really simple interface to a software container that has a machine learning model in it. So you can do simple things like train it or use it for inference without having to learn a new approach to things every time you get a new model. And this is really useful if you want to share it person to person, or if you want to start building infrastructure that can handle a set of different models. The analogy we really like for MLCube is shipping containers. So you think about what a shipping container is, right? It's a metal box of a known size. That is it. Everyone has agreed we're going to make metal boxes. They're going to be this size. But
have you read the book, The Box?
I have not. Is this on the shipping
about
container?
The history of the shipping container?
Wow. Okay, I have to read that because I'm obsessed with shipping containers. But it's amazing. Like we've built this global infrastructure that moves boxes around.
Yeah.
And the infrastructure itself is incredibly complex. And what's in the box might be a load of next generation phones or vaccines or who knows.
Sure.
But it doesn't matter. It doesn't matter how complex the contents of the box are, and it doesn't matter how complex the infrastructure is. They can interoperate because we have this metal box of known dimensions. And that is really what we would like to provide for the machine learning world. It's a deliberately simple project, but we hope it'll be a very useful one. It's one we would like to have. That's always one of the good tests. Is, are you building something you want? Like we have to deal with benchmarks that are a variety of models written in different frameworks. And we would like to be able to build infrastructure that can run them all easily. We'd like to be able to have our members come get them and look at our reference implementations and develop their own that they can submit. They need something like this.
Sure.
But I think the problem is much bigger than that. It's a pretty universal problem, and it's just one of those things that we fundamentally need as a community, and we don't have.
And so going to a little bit more detail there, this container model that you are proposing with MLCube, what specifically is it? Is it a kind of a standard way of setting up endpoints for some REST endpoints for some model that's inside a container? Is it, are we using Docker for this versus something else? Is it?
So it's in its simplest description, it's a standard command line interface to a Docker that contains the model.
Mm-hmm.
It's more abstract than that. So if you can't, for some reason, use Docker, like a lot of the national labs can't for various reasons, mm-hmm. You could have some other sort of container that implements the interface and still interact with it. But if you want the simplest idea, it's a Docker with a command line interface that and understand, regardless of what the model inside of it is.
Mm-hmm.
So that's, Docker's a nice way to package something up and give it to someone so they can run it someplace else. And if it has metadata that describes, what kind of hardware it can run on, you can get that hardware, and make sure you have it so you don't have to worry about compatibility issues. It has all the dependencies you need. It either has the data or it has required to have scripts to get the data.
Sure. Yeah, I'm trying to differentiate what comes for free with Docker, right? Because we've been doing that for a while versus MLCube. It sounds like part of that is the how you parameterize the CLI and standardize it across from one model to the next.
That's basically the primary value add. Like we want this to be as little code as possible. Like the idea here is deliberately create a simple thing that everybody can use. Mm-hmm. But if you have a Docker, if you don't know what's in it or how it works, right. You've only solved part of the problem, right? And so we want to solve the rest of the problem, where you could, I want to write a script that will run this model on every cloud. Mm-hmm. You can do that, right? Or I want to write a script, that will run these 5 models And then, tell me what accuracy I got, because that's what I'm looking for. I'm looking for the best model, right? And previously, you would have had to download each of those 5 models, figure out what crazy way this person chose to implement a machine learning model, right? Get it to work. Chances are it might work, but not exactly the same result they got, because you made some small difference in your configuration, right? And that, with machine learning models, most software either works or it doesn't. Machine learning models, there is a wide range between, doesn't work and works exactly like the author claims. And that's what you want to get, with very little effort. And so that's what we're trying to deliver with this approach.
And is it exclusive to a CLI, or are you also taking on kind of defining the, REST endpoints for a generic machine learning model?
So we have some very basic pieces of infrastructure we call runners that extend it to work in a variety of different ways, but they're all built atop this basic interface. One of the things that we don't want to do is build yet another full stack that competes with other full stacks that are, already out there. What we want is we want that shipping container. People can build complex competing infrastructure above, that people can put different frameworks inside, and just have it all work together so people can choose whatever, is best for them. That's the goal. Like I said, deliberate simplicity, strive for sort of, as close to universal adoption as we can get.
And I mean, you've kind of already said the answer to this, but, in achieving your top level goal, which is enabling some degree of interoperability, for the users of models, there's this container approach, which you've taken. There are also things like Onyx and other interchange formats for the model code itself. Do you have a kind of a perspective or take on the relationship between those things and what you've done, and why you went the way you went, that kind of thing?
So those, like Onyx specifically, is below this. It is a very thin.
Onyx would be inside the container.
Yep. Right. We're talking a bit about how you could share weights back and forth, which is a problem we've run into with benchmarking, where you'd like to have people using very different frameworks for the same model use the same weights. So there's some discussion over how we might achieve that, but this isn't the main focus of MLCube. So that's how it relates to that. I think there's other sort of continuous integration, continuous deployment solutions out there. Things like Kubeflow, one of our early those runners that let it interact with something is aimed at Kubernetes in that world. But that's helping it tie into existing infrastructure, not making that the only way to solve the problem.
Yeah. So interesting to note for folks that are following this conversation, MLCube in this case is spelled with a C, not a C.
Yes.
But I think the parallel is there, right? I think a lot of organizations are, when they're trying to build out a MLOps workflow, a lot of folks arrive at, hey, let's containerize our model and have the container be the artifact.
Yep.
But everyone's kind of reinventing that and doing it differently. And what you're saying is, hey, let's do it the same way. And then you can get a model from anywhere and run it on a Kubernetes cluster without having to know quite as much about what's inside the box.
Exactly. And like I think the parallels to the Industrial Revolution are very strong. Like this is, we need interchangeable parts, right? Where you can buy the part from manufacturer A or manufacturer B and swap it in and it'll work. Right now we don't have that. We have handcrafted by an elite team of engineers in a way that only they are very familiar with. And if you try and remove it and replace it with something from another team of engineers, you're going to have some work to do. And we'd like to get away from that because that's what lets that's part of democratizing ML is to make this possible for people who don't have the expensive team of ML engineers. They can take something and get it working easily and try it out for their problem and create a new business or write a paper in a field that's not directly ML and leverage the value of ML.
Cool. And what's the is MLCube, is it forthcoming, or is there already pieces of that available? Is it state?
Yeah, so we have, MLCommons has a GitHub repo. It's got, the MLPerf benchmarks in it. It's got MLCube. When we figure out how to make data sets efficiently, it'll probably have that in it. We want to build this up and make it available for the community. It's we're open source, Apache 2 licenses. We invite contributions and involvement. This is a model the community has kind of figured out, and we want to leverage that open source model and use it to solve this particular problem to start with, and then work on other similar useful problems. Just trying to make a mature industry where it's easy to do things for a variety of people, a variety of backgrounds and different fields all over the world. Like that is what I think democratizing ML means, which is a phrase a lot of people use, but this is how you put it into practice. You build good public data sets. You give people best practices that make it easy to get models and use them. You give them benchmarks so they understand the trade-offs, or the options they have available to them. This is how you make that happen.
Mm-hmm. Before we wrap up, I'd love to have you share a little bit about, your other hat that you wear on the Google side, running the ML metrics team. What are some of the key things that you've learned about measuring ML in practice at the scale that Google tends to operate?
I think the biggest thing I've learned right now is that it doesn't matter how big you are, but efficiency in ML is going to be critical going forward. Mm-hmm. If you look at, in particular in the natural language models, they just keep getting exponentially bigger. And, we need to figure out a way to achieve those same ends with less training investment, less inference investment. It doesn't matter if you're Google or if you're a startup. This is a really big problem, and it's a big focus from me and my team right now. I think benchmarks actually do have a pretty amazing capacity to drive this forward. I'm escaping the spotlight. If you look at like the ResNet benchmark, which is we put in early as a classic benchmark, we still have it. In about 2 years, we have a 13x top line speed up. We have similar sort of per chip speedups, not quite the same magnitude, but just by software stack improvements. If you give people a measure of speed, they will make it better. If we can combine that with a measure of efficiency in using data or the accuracy of the result you achieve, you can get better results faster. And I something I was trying to do with my team, and it's something we're trying to do in MLPerf and MLCommons. There's a real synergy, I think, between the sort of private commercial world and the public commercial world for metrics, because they're most powerful when everyone agrees on them. Even if you agree on, a imperfect metric, if you all agree on it, you get a tremendous amount of leverage. And so, I think Google's always been a big supporter of, open source initiatives, sort of, community involvement, and they've been no different with MLCommons and MLPerf. So, fortunate enough to be able to try and apply that insight about what matters across my team and the larger community.
Mm-hmm. And MLPerf, this is, I'm sure, an oversimplification, but tends to focus on the first of those three areas, the efficiency, as opposed to the accuracy. And I'm blanking on the last of the three.
MLPerf is constituted today tends to focus on speed.
Yeah,
like how fast can you train it, which is one of the ways to realize efficiency.
Got it.
Right. You have to hold hardware constant to really convert performance into efficiency.
Yeah.
Because one of the other ways to get speed is throw more hardware at it, and that generally does not get you, better results for the same cost. So that's where we are today. Accuracy is, I think, something we're starting to look at. Data sets are, in some ways, the fundamental of measuring accuracy in ML. We had interesting study by one of our members, who's a professor at Harvard, that something like 80% of the papers published by large corporations, you still use public data sets, even though they may have better internal data sets.
Mm-hmm.
because that is the common yardstick that you use to communicate and compare research results.
Yeah.
Yeah. And so, that in some ways a data set is an accuracy metric. And I think there's a more nuanced conversation there about how you construct the test set and, how those two things relate to each other that we would like to explore within the community and see whether we can produce better accuracy metrics. One of our research groups, and MLCommons has a research arm led by a couple of very forward-looking academics, is one of the things that one of their working groups is looking at is how do we use things similar to federated learning for evaluating medical models across large virtual data sets.
Mm-hmm.
They're not doing anything with private data, they're just looking at infrastructure. But if you had a model and you wanted to evaluate its accuracy across a range of different data sets that contain private information that you shouldn't be accessing, but it would be really useful to the clinical world to know whether or not your model works in a wide range of clinical settings. You could set it out, aggregate only the results, which are small numbers, don't contain private information at all, and composite that.
Mm-hmm.
So we're looking at sort of, how do we build these different tools, data sets, this, federated approach, different ways of enabling people to measure accuracy.
Mm-hmm.
And if you bring those two together, we have a group that's specifically focused on this efficiency problem. And they're starting to look at can you isolate the model from the optimizer? Can you say, okay, we're going to hold the model constant and we're going to see whether or not you can come up with a better or worse optimizer. We're going to hold the optimizer constant and see, assuming you can't, hyper fit your optimizer, do you really have a better model or not? And it's that kind of rigorous experimentation that I think gets past, everybody complaining they've got, claiming they've got the best model, the best optimizer, and gets to the point where we really understand what is progress. And, we get these great improvements by building, small optimization on top of small optimization.
Mm-hmm.
But you can't do it without good metrics. If you can't measure it, you can't improve it.
Are there a handful of things that, as you kind of look out at peers in industry at, not Google, or for that matter, other teams at Google, maybe when you first engage with an ML user that isn't, working with your team? I don't know if that's a scenario you run into, but, I'm curious if there's a short list of things that you find that folks could be doing but aren't doing to take advantage of metrics, or to think more, think or do, in a more structured way with regard to metrics that could help them achieve their ultimate goals?
Yeah, I think there are some good lessons about metrics. First of all is start with a really good definition that originates with what you want to measure, not what you can measure.
Mm-hmm.
And then come up with the best approximation that you can measure.
Mm-hmm.
This gets you pointed in the right direction, and you're aware of how far you are from true north as you start to move forward. That, I think, is a really useful lesson. Specifically with respect to ML, that first lesson, that's metrics everywhere. With regard to ML, be aware it's stochastic and plan for that. Right? Like MLPerf, you have to run each result some number of times. That's determined by the variance and the convergence of your model when you're doing training. Models take different periods of time to train. Same model, same data set, even sometimes initialized with the same conditions. Floating point ordering. A butterfly flaps its wings and your model ends up someplace else. Right? And so you have to plan for this stochastic effect and take it into account when measuring things. Don't let someone convince you with a cherry picked result. Make sure you evaluate a range of results. I think that's a useful thing to really think about in ML.
Mm-hmm.
When you're looking at performance specifically, be very aware of normalization. We provide performance results with MLPerf. Sometimes people normalize them per chip, which is better than not normalizing them by anything. But think about whether it's power or cost or what matters to you. And make sure you understand performance per unit, in particular for inference, because inference is infinitely scalable. You give me twice as much hardware, I give you twice as much performance. I think that's a very useful performance insight. So I think those are three pretty good rules. Is make sure you understand what your abstract measure is and how close you are to it. Be aware of stochastic effects in machine learning, and make sure you are normalizing whatever you are doing by some sort of cost metric that makes sense for you and your application.
Awesome. Well, Peter, thanks so much for taking the time to share a bit about what you're up to. Congrats on the launch of this new org, and looking forward to kind of seeing cool stuff come out of it.
Thank you very much for letting me come here and have a great conversation with you. This is was really insightful, and we're very excited about growing our community behind MLCommons. So we encourage people. We're launching on December 3rd, and we encourage people to check out our site MLCommons.org and get involved. We'd love to have you.
Awesome. Thanks so much.
Thanks very much.
All right, everyone, that's our show for today. To learn more about today's guest or the topics mentioned in this interview, visit TWIMLAI.com. Of course, if you like what you hear on the podcast, please subscribe, rate, and review the show on your favorite podcatcher. Thanks so much for listening, and catch you next time.